today we're going to look at non-right triangles and finding sides and angles for those triangles. We use trigonometry, we use some of those ratios to help us do that. But we don't have to have the right angle in the triangle to do that. But we still use the sine function the same way that we did for right triangle trigonometry and for unit circle trig. So looking here, we have a right triangle. We've created the altitude here for this right triangle. One thing to notice is that they've named the angles and sides that are opposite of each other with upper and lower case letters, the same ones. So angle A is opposite of side A, angle B is opposite of side B, and angle C is opposite of side C. This is a pattern and a habit to get into as you're working with these triangles because we do talk about them being opposite of each other using those letters. So for our proof for law of sines, the first thing that we do, again, we have got this right triangle, we've created the altitude or the height, which is h. If I look at the smaller triangle to the left side, I have created a right triangle, so I can set up sine of angle A is equal to the opposite over hypotenuse, which is B. And again, that is just our definition of sine. So we're working through a little proof here quickly for this relationship. We're not just going to let it be something that we assume to be true. We can multiply both sides of that equation by B to get our next statement. So that's the multiplication property of equality that just says what I did to one side of the equation, I've done to the other. We can take the triangle on the right side of the larger triangle and also set up a sine relationship for angle B using our definition of sine. So again, the sine of angle B is equal to the opposite side, which is h, over the hypotenuse, which is A. And again, using our multiplication property of equality, we can say that h is equal to A times the sine of B. So what we've done here in step 2 and step 3, I have two equations that are both equal to h, which is the height of that triangle. If two statements are equal to the same value, we can say that those two things are equal to each other. Mathematically, we call that the transitive property. So if you ever take a class on proof writing, or if you take logic, you'll talk about the transitive property. So if B times the sine of A is equal to H, and A times the sine of B is equal to H, then those two things have to be equal to each other. And then we would use the division property of equality. Now actually they've taken and they've divided 2 times here. They took and divided both sides by B and both sides by A. And we end up with a statement that says the sine of angle A in proportion or ratio to its opposite side A is equal to the sine of angle B in proportion to its opposite side B. So what we've taken and proven in that step is what is referred to as the law of sines. And that actually is typically plural. The law of sines relates its sides and angles using the following formulas. So we proved two sides and angles in proportion to each other. And we actually could have done the same thing and proven the relationship also holds for angle C. So when we are using the law of sines, we don't have to have a right angle. We've taken the right angle out of that equation. We're just using that angle on its opposite side. And so you can use any part of this formula that you need to use to solve. One thing you do want to look for in law of sines is you need to have an angle and its opposite side measure. So an angle measure and opposite side in order to be able to set up and solve these proportions. You can also take and write these as the reciprocals. Because it is just a proportion, we can take and flip all of those ratios over and solve it like this. You just want to make sure that however you're setting it up, if you're putting the side lengths on the top and the angle measures on the bottom, that you do that consistently so that you don't get numbers confused. So let's look at a couple of examples of the law of sine. So for the first triangle, you'll notice that we have 2 out of the 3 angles, and I have an opposite side, which would be opposite of angle C. However, what I don't know is the measure for angle C. So the one thing that you want to remember that you're going to use very often in these types of problems is that all 3 angles in a triangle would add up to 180 degrees. So if I know 2 of the 3, I would subtract those from 180, and in that case, I'm going to have an angle measure of 82. So even if the information is not given, sometimes you can use other things that you know about triangles to help you find that information. So now that I have a angle measure and its opposite side, I can set up the proportions. So the sine of 82 over its opposite side, which is 2.68, is equal to, in this case we can say we're going to solve for the side length AC. I'm going to call that x. So the side, or the angle opposite that, is 34 over x. Because this is a proportion, we are just going to take and use cross multiplication to solve. So x times the sine of 82 is equal to 2.68 times the sine of 34. So remember that the sine and the angle, those two things are joined together. That's a ratio on that table for sine values, so we can't break that apart and just work with the 34. We would have to keep that together. Then I can divide both sides by the sine of 82. And then at this point, you're going to have to do that work in your calculator. Make sure that your calculator is in degree mode so that you're getting the correct answer. And so once I type in 2.68 times sine of 34 and divide that by sine of 82, then we should get 2.42. We can also set up and solve for our other side length. We can call that y. Once you've solved for another side, you can use that other relationship to solve. I typically go back to the one that I've been given just to make sure that I am solving correctly. So sine of 82 over 2.68 is going to be equal to the sine of 64 over y. Again, we use cross multiplication. 2.68 sine of 64 is equal to y times sine of 82. Divide both sides by sine of 82. So what we have to type into the calculator is 2.68 times the sine of 64 and divide that by the sine of 82. And we would see that we have the other side length of 1.51. And so when we are finished, if they have asked us to solve the triangle in any of these problems, that means they want you to give all 3 angle measures and all 3 side lengths. So we were able to solve for the angle using the triangle angle sum, and then we used law of sines to find the other 2 signs. So let's look at some other examples in just a second. We have to talk about first this idea of an ambiguous case. And so the ambiguous case says that if the angle in your triangle, information in triangle is given as side-side angle, meaning you have 2 sides and a non-included angle, and sometimes you have to go back and think about your triangle congruencies and how we used to name those in the triangles to help us with these problems. So 2 sides and a non-included angle, and if the angle given is acute, we can have more than one triangle possible. And this comes from the fact that on our sine curve, if we think about a triangle, we're only worried about values through pi or 180 because triangles can never be more than 180 degrees. But a sine graph is not a one-to-one function, meaning that for a certain sine value, it's possible for me to have more than one angle with the same sine value. So sine is not one-to-one. And so if one of these angles is less than 90 degrees, an acute angle, there's going to be another angle on the other side that is going to also give us that sine value. Your calculator is programmed to only give you the smaller of those two numbers. So your calculator recognizes basically the fact that there's more than one answer, but it is programmed to give you the smaller answer. So you have to be able to recognize this scenario yourself and know how to find the other angle. The way to find that other angle is to take 180 and subtract the angle that you're given, and that's going to give you your other possible solution. So let's look at some examples where this is going to happen. So for this triangle, the measure of angle A is given as 20 degrees, so I can start setting up and labeling this triangle. A is 20. If they hadn't given me that picture, I would know they were opposite of each other because they're the same letter. And then B is 32. So the sine relationship here would be sine of 20 over 20 is equal to sine of B over 32. The other thing you have to notice here is we're not solving for a side length, we're solving for an angle, which means we're going to have to use inverse trig functions on the calculator. We still use cross multiplication, so 32 times the sine of 20 is equal to 20 times the sine of angle B. Divide by 20 on both sides. So on your calculator, you're going to need to type this in as the inverse sine of that number. And when you do that, your calculator is going to tell you that angle B is equal to 33.17. And if you're checking your work here, when you get this number, you should get something close to 0.547. So inverse sine 0.547, angle B is 33.17. Well, 20 is an acute angle. So if I think about all of these angles inside of a triangle, if one of my angle measures is 33 and one is 20, then I can find the third angle by subtracting from 180. The other possibility is by taking 180 minus 33.17, and that angle would be 146.82. Well, if I add 146.82 and 20, that's 166.82, which means there's enough angle measure left there that I could actually have two triangles for that sine relationship. So you have to kind of think and process through that, right? Just making sure that you don't end up with more than one triangle. Or excuse me, you have enough angles left to create a triangle. So for this one, we actually have two possible solutions. We could have an angle of 33.17 degrees or 146.82 degrees and still be able to make a triangle. All right, in our second example, the measure of angle A is 58, so it is still an acute triangle. A is 25 and B is 22. So we go ahead and set up sine of 58 over its opposite side is 25. That's going to be equal to sine of B over 22. So we're going to work on our cross multiplication. So 22 times the sine of 58 is equal to 25 sine of B. We divide by 25 on both sides. So the sine of B is going to be equal to about 0.746. We use the inverse function on the calculator. Oh, we want to put the number there, not the variable. So 0.746, and that's going to give us angle B. So when we type that into the calculator, we would see that angle B is going to be equal to 48.27 degrees. And then we also have to find the other possible angle measure, which would be 131.73. So again, we get that by subtracting from 180. So we have to go back to our triangle. If we had 180 degrees and we know that we already have one angle that is 58, that's going to leave us with 122 degrees that has to be split between angle B and C, which means that this number is too large for the triangle. Because if I have 131 and 58, I'm going to be over 180 degrees. So the 48.27 is the only possible solution for this triangle. So you want to check and verify all of your answers to make sure that you're listing them. But in this case, I'm going to break that 180 rule, and so there's only one answer, so angle B has to be the 48.27. And in our final example, the measure of angle A is 65, so again, we're still an acute angle. A is 18, B is 22, so sine of 65 over 18 is equal to the sine of B over 22. Cross multiply, so hopefully you're starting to kind of pick up on some of these processes and you can work through these a little bit faster than I've been in these examples. So again, we would take our inverse sine of B and then simplify that 22 times sine of 65 and divide it by 18. And then sine of B is 1.1. Now, if you put that into your calculator is going to yell at you and tell you that there's a problem with that. The reason that you should be able to see that there's a problem with that is that we know on our sine graph we can never have a sine value above 1. And so your calculator can't solve for that. You're not going to be able to solve for that. So our answer for this scenario is that there is no possible solution. So if you get an error, just go back, make sure that you have all of your angle measures set in the right places and in the right relationship. And then if you get a sine value greater than 1 or something less than -1, you know that's not possible because we can't have a solution for that. So using law of sines, you do have to be careful for the ambiguous case because it is possible to have one solution, two triangles as solutions, or no triangles as solutions in these problems.